Let's do another example using the quadratic formula to solve a quadratic equation. This problem can't be factored. My product here is 1 times negative 3, and my sum is 5. I can only build negative 3 by 1 times negative 3 or negative 1 times positive 3. Adding these two gives me negative 2. Adding these two gives me positive 2. Neither of these comes out to 5. So this cannot be factored. There's no way to write this in this form. So in this case, I'm forced to use the quadratic formula if I have any chance at all of solving this equation. The quadratic formula says that if my quadratic equation is in this form, then x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So first I have to go make sure that my equation's in the right form. Are the terms in descending order of power? Highest power of x first, then next highest, and then the term with no x at all? Yes, it is. Now that I've determined that everything's in the right order, I also need to make sure that the right-hand side is equal to 0. And that's okay here as well. Now that I've checked those two things, what are a, b, and c so that I can plug them into my formula? A is 1 in this case, b is 5, and c is negative 3. I'm going to rewrite the formula with empty parentheses. There's my negative b, plus or minus the square root of b squared minus 4ac all over 2a. Then I can go back and either starting from the left and working to the right and then down, or starting with a and then going to b and then c, whichever works for you. I'm going to fill in the blanks. I'm going to start at the left and work my way along this time. This was supposed to be negative b. Negative b is the first thing that occurs in the formula. Since b is 5, I'll fill this particular set of parentheses in with a 5. The next thing I come to is another b, but it's b squared. That's okay, I already have the thing squared, it's just that I have to figure out what thing goes in that space. The next thing I come to is a. My a was 1. The next thing in my formula is a c, and c is negative 3. The last space that needs filled in is a. That's the filling in part. All we have to do now is arithmetic. This is equivalent to saying negative 5 plus or minus, and the work I need to do in here now is as though it's in parentheses. My exponent first, then my multiplication, and only in the next step will I subtract those two. 5 squared is 25. This multiplication here is 4 times 1 times negative 3. 4 times 1 is 4. 4 times negative 3 is negative 12. I copied this minus sign over. So I'm only multiplying 4 times 1 times negative 3. Another way to think of this is addition of the opposite of 4 times 1 times negative 3. So I'm going to add negative 4 times 1, which is negative 4, times negative 3, which is 12. In the previous version I had minus negative 12, which would have turned out to be positive 12. You can do it either way. Just be careful that you get the right sign in there. The denominator of this fraction is 2 times 1, which is 2. Since I'm still working in what's effectively a grouping symbol, the next thing to do is this addition. What I have above turns into negative 5 plus or minus the square root of, and that's all going to be over 2. This is the piece I'm not doing anything with yet. Now I'm going to go back in and do this addition. 25 plus 12 is 37. Well, if that had been 36, I'd have been able to take the square root, because the square root of 36 is 6. But it's not. 37 is not a perfect square. Does 37 break down? Can I simplify the square root of 37? No, it doesn't break down at all. So it turns out that this is actually my final answer. I can write it one of two different ways. Either x equals negative 5 plus or minus root 37 over 2, or x equals negative 5 plus root 37 over 2, and negative 5 minus root 37 over 2. On paper, I don't care as long as you get them both. This is actually two answers here. One or the other of these would be fine for full credit on the final exam. How you enter it in WAMAP depends on how the particular question is asked. I will point this out though. In WAMAP, to type this in, you need to type negative 5. To get this symbol, type plus and then minus right next to each other. WAMAP will know what to do with that, and when you hit the preview button, you'll see that it's turned into this. Then type SQRT for square root, the thing you're taking the square root of in parentheses, and we want to divide all of this by 2. So we have to tell WAMAP that all of this is my numerator, so that it knows to put the whole thing over 2. This answer on paper needs to look like this in WAMAP. The problem we did before had nice answers. Okay, one of them was a fraction, but I could evaluate the square root. I could take it further. In this case, I can't. Let's take a look at one more, where I might not be able to take the square root per se, but I can simplify it. And that means I might be able to simplify the whole fraction. This is another one that won't factor. I can tell by looking at the fact that 1 times 2 is negative 2. And negative 2 can only be written as negative 1 times 2 or 1 times negative 2. Adding these up gives me 1. Adding these up gives me negative 1. These numbers are small enough that I can do this check quite quickly. Neither of these gives me this, so this will not factor. The only way to solve this equation is by using the quadratic formula. First of all, is it in the right order? The first term is x squared, the second term is x only, and the third term has no x. So they're in the right order. What's the next thing we need to check? Is the right-hand side equal to 0? That's also already the case, so we're good there. Finally, what are a, b, and c? A is 1. B is negative 2. And C is also negative 2. Now I'll write my formula with empty parentheses. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You don't need to memorize this formula, by the way, at least not for me. Future instructors may expect you to know this by heart, but for this class, I'm much more concerned with your learning how to use the formula, checking that all the requirements are met. These are in the right order, the right-hand side is 0, and being able to identify A, B, and C, plugging them in correctly, and being able to do the arithmetic correctly. That's far more important to me than whether or not you can memorize a formula. I can't speak for your future instructors, but that's one of the reasons I let you use a 3x5 index card on your exams. Write the formula on your index card. Maybe even make a note that you can write it either like that or like this. Make a note that this is B, this is A and C. But writing it with empty parentheses in place may in fact help you remember to do that. And then when B is a negative number, as it is here, you won't make the mistake of forgetting to square -2. That's just a suggestion. Of course, you're going to do what works for you. For now, we have work to do. Negative b plus or minus the square root of b squared. B is -2, so that goes here and here. Minus 4 times a times c. A is 1 and c is -2. All over 2a. A is 1. Now that I've filled in the spaces, all I need to do is the arithmetic. -2 is +2. Inside the grouping symbol that is the square root, -2 squared means -2 times itself. -2 times -2 is +4. If you ever get a negative number in this step, something's wrong. This will always be a positive number because I'm squaring a number. And whether I square a positive number or a negative number, the answer will be positive. There will be times when you might end up with a negative under the square root, but this number should always be positive. Now, where was I? Here's my -2 squared. What I need to do now is multiply -4 times 1 times -2. -4 times 1 is -4, and -4 times -2 is 8. 2 times 1 is 2, and I can continue and do the next step. 4 plus 8 is 12. All I'm doing is addition. It's kind of like I'm doing it in parentheses because inside the square root, things behave differently, so we have to keep them together. In the last problem, we stopped here. But in this problem, there are 2 more things I can do. One is to simplify the square root of 12. The other is to reduce the fraction. We need to simplify the square root of 12 first. On scratch paper, I'll make a note that 12 can be written as 4 times 3, and 4 can be written as 2 times 2. So that means that 12 can be written as 2 times 2 times 3. If that's true, then the square root of 12 can be written as the square root of 2 times 2 times 3. That is 2 times the square root of 3. So I can replace root 12 with 2 root 3. That means I can rewrite this problem like this. Instead of root 12, I can write 2 root 3. These are equivalent. Now that I've done that, though, there's one more thing that I can do. Remember that conversation we had earlier about reducing fractions? This is times, 2 times the square root of 2. But this, plus or minus, not only is that a plus or a minus, it's both. That is a big red flag. I cannot reduce this fraction simply by canceling these 2's. If I'm going to cancel this 2, then I have to cancel it with not only this 2, but this 2 as well. Not this one, because this is not 2, it's the square root of 2. Remember, things inside the square root behave differently. I can think of what I'm doing here in a couple of different ways. One is to say, rewrite the fraction as the sum, in this case a sum and a difference, of 2 fractions with a common denominator. When I do that, it becomes clear that this 2 cancels with this 2, and this 2 cancels with this 2. If I put these fractions back together again, you can see that these 2 2's are really just this 1 2. So as it's written here, canceling each 2 in the numerator is obviously going to need to be canceled with a 2 in the denominator. But if these two 2's are really the same 2, well, then I have to cancel these both with this one. Here's another way to think of this, though. 2 plus or minus 2 root 2 has a common factor of 2. In other words, I can undistribute 2 from this expression in the numerator. When I undistribute 2, I'm left with 1 plus or minus root 2, and the whole thing is still divided by 2. Now I can see that since this is times, what I'm doing is canceling like factors. If I factor the 2 out first, then I'm just canceling the 1 copy of 2 on the top and the 1 on the bottom. The reason I can't do that here is because it's across a plus, not across a times. Can you see the difference? In either case, what I end up with for my final answer is 1 plus or minus the square root of 2. Here, since I canceled my 2's, what's left is 1 plus or minus root 2. And here, when I cancel my 2's, I end up with 1 plus or minus 1 root 2, or just root 2. So this is my answer. I arrived at it 3 different ways. Like everything else, you can use whichever method works for you. Just don't forget to cancel all of the 2's. This is really important, and it's a very common mistake. So if this is something that you struggle with, make some time to go back over that idea and make sure you don't make the mistake on an exam. Here's our next one. This equation cannot be solved by factoring. 1 times 2 is 2. My product is 2. My sum is 1. 2 is 1 times 2, or negative 1 times negative 2. This is 3, this is negative 3. Neither of these equals 1, so factoring won't work. So we have to use the quadratic formula. But the quadratic formula just says, as long as ax squared plus bx plus c equals 0 is in the right form, in the right order, and equal to 0, then identifying a, b, and c and plugging them in will give us the values of x that satisfy this equation. So let's identify a, b, and c. A is 1. B is also 1. And c is 2. Negative b is negative 1. Plus or minus the square root of b squared is 1 squared. Minus 4ac is minus 4 times 1 times 2. Over 2a is over 2 times 1. Doing my arithmetic, I now get negative 1 plus or minus the square root of 1 squared is 1, and negative 4 times 1 times 2 is negative 8. And that's all over 2 times 1. In the next step, I'll do this addition or subtraction inside the square root. This is just the stuff I'm not working with right now, but I've written it down anyway because I don't want to forget about it. 1 minus 8 is negative 7. Now, go all the way back, almost to the beginning of the quarter, when we talked about square roots and whether or not you could evaluate a square root. What number times itself is negative 7? Well, first of all, there's no perfect square, but it doesn't really matter whether we're talking about a perfect square or not. There is no way to evaluate the square root of a negative number. Negative 16 is negative 4 times 4, or 4 times negative 4, but these numbers are not identical. I could write this as negative 1 times 16, and then I could get, from that, I could get 4 times the square root of negative 1, but I still have a negative 1 in the square root. I can't take this square root. Even though I've reduced it to a smaller, slightly different problem, I still end up with a negative inside the square root. The only way to deal with this is negative 1 times 1, and those are not identical, so there's just nothing I can do. The same thing applies here. It doesn't matter whether 7 has a perfect root or not. The fact that it's negative 7 inside the square root means I can't take this square root. Not only that, there is no number that makes this true. Therefore, there's no number that makes this true. So even though we've done all of this work, my ultimate answer here is no real solution. It turns out that there is a way to work with the negative number inside a square root, but that's more than we need to worry about for this course. If you're working a problem that at any point has a negative number as the result of the arithmetic you do in the square root, then the answer is no real solution. In Math 98, we look at what it means to be a solution to a quadratic equation. We graph quadratic equations. We compare the solutions to quadratic equations to where our graph crosses the x-axis. Halfway between the places where the graph crosses the x-axis is the highest or lowest point of the graph. There are lots of reasons for knowing how to find the solution to a quadratic equation, and they're not always going to be whole numbers. They're not even always going to be fractions. This example didn't have a solution at all. The previous example had solutions, but to leave them written in exact form, they weren't very tidy looking. They are from my point of view. Once you've done math for a little while, you come to expect things to take a certain form. And the answer we came up with for our last 2 or 3 examples, in fact, looked absolutely fine to me, because I'm used to working with them in that form. Remember that I'll want your answers in exact form, so don't turn around and change it into a decimal. Even though it may look tidier to you and give you a better idea of the size of the answers you've come up with, it won't get you full credit unless your exact form is also part of your answer. There's a lot more to learn, because there's a lot to algebra, but you've learned a huge amount in this course. Manipulating linear expressions and quadratic expressions, solving linear and quadratic equations by multiple techniques. You've learned about inequalities, how to solve them, how to graph them, and how to represent them using inequality notation. You've learned something about polynomials. You know some vocabulary you might not have come to the course with. Polynomial, monomial, binomial, trinomial. You've learned how to multiply polynomials, add them and subtract them, divide them. You've learned how to do distribution, and you've learned how to undistribute, factor. You've covered a huge amount of material. Good luck on the final exam, and good luck in Math 98 and all your future courses. Thanks for joining me on this adventure.